This video is prepared by Avya Classes. Please subscribe the channel, raise your doubt and watch the video for sure success in JEE, AIMS and NEET. Friends, now we will discuss elastic potential energy. So what is restoring force and the spring constant? If a spring having natural length equal to L, which is shown in this figure, is stretched by or compressed from its normal position, that is from x is equal to 0, by a small distance x, then a restoring force is produced in the spring which wants to bring it back to the normal position. So this is shown in this figure. This is our spring having a spring constant equal to k and its natural length is equal to L. The mass m is attached to the spring which is currently at its normal position, that is x is equal to 0, and in this case we have not applied any external force on this. As we have not applied any external force, or the spring has not been stretched or compressed, so there is no any spring restoring force. Once we want to stretch the spring after application of an external force denoted by F external, correspondingly restoring force is produced in the spring which wants this object to move its normal position. That is, this restoring force wants to nullify the expansion in the spring. Similarly, if we see the case 3, which is the compression of spring, here the external force pushes this mass and it produces a compression in the spring. So a restoring force is created in the spring which wants to move the object to its normal position or nullify the compression in the spring. Now we will learn the direction of this spring restoring force. So suppose in this case, when we compress the spring and the spring is compressed by a length equal to x, so due to this expansion, a restoring force is produced in the opposite direction of this displacement. That is, the restoring force is produced towards minus x axis. If you consider this as x axis, this as a y axis, then the restoring force is produced towards minus x axis, and this restoring force wants to nullify the compression of this spring. Similarly, here as the compression is produced in the spring, so the restoring force will be towards positive x axis which wants to nullify the compression. So in both cases we have seen that the spring restoring force is opposite to the displacement, or it's opposite to the direction in which object moves. So based on this concept, we will calculate the value of spring restoring force. So the spring restoring force is given by the Hooke's law, and Hooke's law says that this restoring force is proportional to the displacement x. That is, restoring force F is directly proportional to the displacement. Second thing is that the direction of restoring force is always opposite to the displacement. That is, if the direction of displacement is towards positive x axis, then the direction of restoring force will be towards negative x axis and vice versa. So in terms of vector sign, we may write that vector F is directly proportional to minus vector S. So the restoring force, or the spring restoring force, which we denote by Fs, is directly proportional to minus vector S, and if I write a constant of proportionality, then it is equal to Fs is equal to minus Kx. So this is the formula of spring restoring force. So clearly F is, or vector F is equal to minus K into vector S. So if I put the value of x is equal to 1, that is, if I compress or expand the spring by a unit length, then the force is equal to K. So how we define the spring constant K? Spring constant K is basically defined as the stiffness or softness of the spring, and it is numerically equal to the force required to produce unit displacement in the spring. So spring constant K is numerically equal to force required to produce unit displacement in the spring. So higher the value of K, then the spring is said to be more stiff, and vice versa. So if we increase the value of K, or if the spring constant K will be more, then the spring will be more stiff, more stiff, and in this case you need more force for the unit displacement. So clearly high K, high force, and the K less force required to for the same displacement will be less. So actually K is the measurement of stiffness or softness of the spring. So based on the Hooke's law, we may say that Fs is equal to minus Kx, and K denotes the stiffness or softness of the spring. Now we will learn the unit and dimension of K. So what is the unit of K? So the SI unit of K is Newton per meter. K is equal to F by S. Numerically we may write K is equal to F by S, and the SI unit of F is Newton, while the SI unit of X is meter. So we may write the SI unit of K is equal to Newton per meter. So it is Newton per meter. Similarly, if we calculate the Cgs unit, then the Cgs unit for force is equal to dyne, and for displacement it is equal to centimeter. So the Cgs unit for K will be dyne per centimeter. And if we have to calculate the dimension of K, then for this we just write the individual dimension of F and X. The dimension of F is mLt minus 2, while dimension of X is equal to L. So we get the dimension of spring constant K is equal to mt minus 2. So the dimension of K is equal to m raised to power 1, L raised to power 0, and T raised to power minus 2. This dimension of force constant is similar to the dimension of surface tension. This is the important concept. Sometimes it asks in the examination.